Now that we have had a chance to practice drawing pictures and having fun there, let's actually try solving some problems. This is, again, like I've said before, where trigonometry is very useful to find in problems like this. So this right here, starting off here, I'm going to talk about some trig applications. These right here are just some steps for us to do. Make a drawing, write an equation, and solve. Pretty simple. And I know sometimes we want to skip the make a drawing and go to writing an equation, but that make a drawing I think is really important because it helps us visualize. And maybe that's why I enjoy this drawing so much, is because I'm a visual person myself, and so I like to see things, and it helps me visualize. And so I think for you to draw these as well, they will help you visualize. So let's go over some problems. I don't know if we'll go through a lot of these, but let's see what we have here. Carrie places a 10-foot ladder against a wall. If the ladder makes an angle of 65 degrees with the level ground, how far up the wall is the top of the ladder? So I would draw a picture again. So we have Carrie right here. Beautiful, isn't she? We have a wall right here. Okay. And Carrie is going to place a ladder up to the top of the wall. The ladder, label as much as you can here. The ladder is 10 foot tall ladder. And the angle that the ladder makes with the ground is 65 degrees. One thing I do want you to notice here is that what kind of triangle have we made here? We have made a right triangle. We know all things about right triangle, especially, I'm going to write it down here, SOHCAHTOA. Anytime you see a right triangle, SOHCAHTOA right here should really ring through your ears. We want to find how far up the wall is the top of the ladder. So we want to find this right here. I'm going to call that X. Just like with any right triangle, we know this angle. Let's label the triangle according to that angle. Which side is opposite? This side is opposite. Which side is adjacent? This side is adjacent. Where's the hypotenuse? Always across from the 90-degree angle. So like we've done before, we're looking for an opposite. We have a hypotenuse. Which of these three uses opposite and hypotenuse? It's the SO. So here I can say the sine of 65 degrees is equal to the opposite over the hypotenuse. And then to solve, we're just going to multiply both sides by 10. Right here, that's what I'm going to enter into the calculator. I'm going to go to my handy dandy calculator here. I'm going to enter 10 times the sine of 65. Looks like my answer is 9 point. Let's round to the nearest tenth. From everything we do here, just to the nearest tenth. 9.1. So we can say this goes up the wall 9.1 feet. And there's our answer. Okay, next one. A flagpole casts a shadow that is 15 feet long. The angle of elevation of the sun at this time is 40 degrees. How tall is the flagpole? Again, let's start off by drawing a picture. Here's our picture. Here's our flag. It mentions the sun in there. I like to draw the sun. Even though my suns look horrible, I draw very nicely, don't I? Put some red in there. Okay. The flag is casting a shadow. The shadow is 15 feet long. This is the angle of elevation of the sun. Where is the angle of elevation? This case, it might be a little bit different here, but we're going to start down here where the shadow ends and goes up to the sun. And this right here is our angle of elevation, and that is going to be 40 degrees. Again, if you notice, we have made a right triangle. Most flags are perpendicular to the ground. We want to know how tall the flagpole is. Again, label. Where's the opposite side? Where's the adjacent side? Where's the hypotenuse? I'm going to write SOHCAHTOA over here. Which of these three am I going to use? I have an opposite and adjacent. What over here uses opposite and adjacent? The TOA. So I can say the tangent of 40 degrees is equal to the opposite over the adjacent. Multiply both sides by 15. Right here, that's what we are going to enter into the calculator. So I'm going to come back to my calculator here, clear everything. 15 times the tangent of 40 degrees. And what do we have? 12.58, so let's round to 12.6. So x is equal to 12.6. And let's make sure we put our units, which is feet. In Southern California, there's a 6-mile section of Interstate 5 that increases 2,500 feet